Chapter 4, Structuring System Requirements. So we will discuss this issue today. And let's talk about process modeling and graphically represent the processes that capture, manipulate, store, and distribute data between a system and each environment and among the system components. So basically, the process modeling is, of course, is a very important concept, an important component actually for the system development, because without understanding about the process, and then definitely you cannot develop the correct or right system for the company. So that's why, in order to understand all the process, especially the processes associated with the information system, we need to use a certain tool called the data flow diagrams, so DFD. So DFD technically is the DFD illustrates the movement of data between external entities and then processes. So processes are more like operations, right? Processes and the data stores within the system. So modeling a system process is a system process. You technically utilizes the information gathered during the requirement determination. So basically, it uses use case analysis. Okay, result from the use case analysis. So we mentioned this one previously, and also the structure of the data is also modeled in addition to the processes. Okay, so data structure should be considered in the process modeling. And deliverable outcomes of the process modeling is a set of coherent, interrelated data flow diagrams. Also, context data flow diagram, DFD, and we will learn about this one. So in this time, we will draw DFD a lot. And then DFD is the current of the current system enables an analyst to understand the current system. So technically, we draw this flow, this diagram, to understand existing system clearly, okay? And DFDs of the new logical system show the data flow, structure, and functional requirements of the new system, okay? So it's a technology independent. So in this case, definitely by using DFD, and then you can have clear idea about the entire system, as well as the data sources needed for the system development. Again, okay? And project dictionary and case repository can be used here. So let's look at the notation, okay, used for the DFD. So here we have 4 symbols, and one is a data flow. So technically these arrows with name actually represent the data flow, and the data store. So this one, data store, okay, and then source and sink. So the source and sink is this one. So technically the external, or you can illustrate this one as an external entity, okay, external entity or object. So usually this one is actually component such as customer, okay, or the manager or something like that. And then this one is a process. So process has a rounded edge here. So this one is a square, okay, a rectangle. So process, every process has a number, name, and also the description, okay, is optional, but description. So also this, once it has a process, there is a process, and it should have at least one output data flow and then one input data flow here. So input, output, kind of hard to understand it, right? So input data flow and then output data flow, okay? And data flow, again, it should have a name so that you can understand what kind of data actually can be delivered to the another like a component, right? Such as a process or the external entity, right? Right. So one or more connections to the process, definitely. So this is a condition, and data store has also name, and then this is the ID, okay? So it's an index, and one or more input data flow, and one or more output data flow. So if there is a data flow, definitely it has one, should have an input, output, okay, at least one, okay, one more. And external entity has a name as well as a description, but usually description is hidden, so you can only see the name. Okay, data flow. Data flow depicts data, which is arrow, right? And name, and in motion and moving as a unit from one place to another in the system. Drawn as an arrow, I already mentioned this one, right? And then select the meaningful name to represent data. And store, so meaningful name, which means, so this name should mean something, right? If you just use a tool or the random name, something LND, something like that, then no one can understand this one, right? So if you have an arrow and then this one, you should provide what kind of data type or what kind of data actually follow this arrow, right? So customers request something like this, okay? All right, data store, depict data at list, and then may represent the data in file folder, computer-based file, notebook, okay? The technical laptop, right? So notebook, so this one is just notebook, which means it's not the laptop, notebook, note, right? And then drawn as a rectangle with the right hand vertical line missing, and then right level include the name of the store as well as number. So which means the shape is like this, okay? So this is an index and this is a name, okay? So this is a number and the name. Process depicts work or action performed on data so that they are transformed, stored, distributed, okay? Drawn as a rectangle with rounded corner. I already mentioned it, right? Rounded corner, yes. And number of processes as well as name are recorded. Number, process name, purchase, something like this. All right, source sink depicts origin or the destination of the data, sometimes referred to an external entity. Okay, source sink, external entity, yeah, these are the same thing. So square or rectangle, and drawn as a square symbol, which is which has this kind of the sharp edge, and name states that what the external agent is, and then because they are external, many characteristics are not interest to us. So it's a customer, something like customer. We don't have to know about, we should understand the customer, but we don't have to spend time to understand everything about the customer, right? So if customer send a request, we will respond to the request, something like that. Example of DFD. So see, we have customer here. Also, we have bank here. So these are the external entities. And also we have 1, 2, 3 processes. Record payment and then make a bank deposit, update customer master, okay? So and then payment, if customer pay something, pay money, right? And then definitely this process will send the payment data to the another process, right? So that make a bank can make a deposit, right? Save the money and then update the customer's master so that customer can get receipt, right? About the deposit. And then bank keep that money, right? All right, and then create data to the customer master so that you have a account information, and then okay, so now we have $10,000 here in deposit, right? So total will be 10,000, something like that, and deposit data goes to the bank, right? So this part is a system, right? And then we have two external entities. Context diagram technically is used, okay, in the data flow diagram. So technically, we did draw this one before we developed the data flow diagram. So let's look at this. So scope of the DF diagram, actually before you develop the DFD diagram and DFD, I'm sorry, data flow diagram. Yeah. Data flow diagram, DFD, and then definitely you should understand scope of the organization system, right? They should be developed, right? So particularly, you need to understand system boundaries, external entities, right? Interact with the system. So in order to do that, you have to develop the context diagram. It's more like a conceptual model, okay? Summary of the DFD. A level 0 diagram in DFD is a more like technically it's a more like it's a real diagram actually to develop the system. So represent the system's major processes, right? Data flow, data stores at high level, still high, and so we have level 1. Oh, where is the level 1? So I will mention the level 1 later. So here is an example. So of the Hoosier burger, automated. So there is an automated food ordering system. If you go to the McDonald's nowadays, if you go to McDonald's or the Burger King, and then you can see the automated food ordering system, right? So let's look at the Hoosier Burgers automated food ordering system here. Step 1, you need to draw the context diagram. Contains no data stores. So as you can see, there is no data stores, right? So we don't have this one here. And then external entities, 3 external entities, and then one single, so one system here, process, okay? So basically, it only give us the relationship between the external entities and the system, right? However, we want to understand more about the system, right? In order to develop it. So next step, you can actually expand the context diagram to show the breakdown of the process. So level 0, level 1, level 0 diagram. So here, customer, kitchen, and restaurant manager, and then now you have multiple processes directly connected to the each external entity, right? So initially, a customer order something and then receive food, right? So basically the receipt, right? Receive the receipt, and then receive and transform customer or food order will send the goods sold data, also inventory data and food order to the kitchen. So kitchen can make something, right? Right, and then update goods sold file here, and then update the inventory data source here, and then since it has one input, and then you should have output as well, right? From the data source, also the process, same thing. So send this information to the fourth process, which is produce management report. Okay, so management report will be generated. Okay, so this one is only taking the order. This system is only taking the order from the customer. Okay, it didn't consider the food delivery, right, after the order receipt. Okay, anyway, basic rules that apply to the DFD, all DFDs. Input processes are always different than output. So input are different, okay, from the output. Object always have a unique name. Okay, you cannot use the same name twice or multiple times. In order to keep the diagram unclustered, you can repeat the data store and data flow on the diagram. Actually, when you develop the system, when you develop the program, you cannot use the same name several times. You know that, right? So this will help us to avoid the mistake, right? Naming mistake. Okay, process. So no process can have only one output, or no process can have an input. So once it has an input, and once it should have an output as well, right? Process. So check the arrow. Okay, and then process has a verb phrase label. Okay, data store. Once again, cannot be moved from the one store to another. Okay, you cannot send something without have a process, right? From the one data source to another data source. Data cannot move from an outside source to a data store. Data cannot move directly from the data store to the data sink. Okay, and then data store has a known phrase label. Source sink, right? Data cannot move directly from the source to sink. Okay, and then source sink has a known phrase label, and then also data flow. Data flow has one direction of the flow between symbols, and then yes, so one direction. Do not use both direction. Okay, a fork means that exactly the same data go from one common location to two or more process data store. So fork. Okay, so one source to the multiple destinations. Same data. Okay, name. Also, plus data flow. Okay, continue the data flow. A join means exactly one same data come from the two or any two or the more different processes. Join. Okay, and store sync to the common location. And data flow cannot go directly back to the same process you leave. No recursive. Okay. And data flow to a data store means to update. And data from a data store means to retrieve, update. Okay, provide the information and then receive the information, right? And before you receive the data, provide data, right? That's the meaning of this terminology. And then this word. And data flow has a known phrase label. The user known anyway. So anyway, functional decomposition, act of going from one single system to many component processes. Repetitive procedure, lowest level, is called a primitive DFD. So functional decomposition, so level and diagram. So we are going to talk about level and diagram to see the detail level, lowest level of the function. So a DFD, that is a result of the n-nested decompositions of the series of the sub-processes from process on the level 0 diagram. So according to the system level, actually, complexity of the system, you can have level 1, level 2, level 3, and so on. So that's why people called level n, right? Level n diagram. Sometimes you have level 1, level 2, but sometimes you have level 5 or something like that, according to the levels, the complexity of the system. So when decomposing DFD, you must conserve the input and output from process at the next level of the decomposition. This is called balancing, so it should be balanced. Okay, so when you have a more detailed information, for example, customer, kitchen, and restaurant manager, right? Using the food ordering system, and then still same, right? Name here, right? This is a balancing, right? Although internally itself has 4 other processes, but you can merge it, right? And then you can, so this process is decomposed, right? With 4, 1, 2, 3, 4 processes, right? It's just easy, right? Use the same name. All right, with different level. So okay, keep the same name for the same rule, and then okay, and then if you look at this burger system, and then there was one input to the system and the customer order, right? And so 3 output: customer receipt, food order, major import report. So customer order, 3 output, right? Good. And I already mentioned that this is balanced, right, with this level 0, right? Why? Because everything is still same, right? And then this interaction is the same, okay? And then this one is still same, and then food order is 1, right? So number of data flows are also same, right? With the context diagram, right? Let's continue the balancing about the diagram. So here you have a context diagram and level 0 diagram, and then definitely source, sink, right? So in context, we have 1 input to the system, A, and then 1 output, B, right? A, B. Level 0 diagram has a 1 additional data flow, C. So, which means not balanced, right? Incorrect. Right. We can split the data flow into a separate data flow on the lower level diagram. So if let's say you have 1 data flow here, however, you can actually specify split this one process into the two, so like x.1, x.2, right? In that case, you can have a disaggregated data flow. If you merge it, you can have this one. If you decompose it, you can have this one. Okay, decomposition and aggregation. This is aggregation, decomposition. Advanced rules for governing DFD. Okay, component data flow on the one level can be split into the component data flow at the next level, but no new data can be added, and all data in composition must be accounted for the one or more subflows, and the input to a process must be sufficient to produce the output. Okay, so detailed information is better from the process. Thus, all output can be produced and all data in input move somewhere, either to another process or to a data store outside the process, or one or more detailed DFD showing a decomposition of the process. At the lowest level of the DFDs, new data flows may be added to represent data that are transmitted under exceptional conditions. These data flow typically represent error messages and customer not known. Do you want to create the new customers or some confirmation notice, something like that? So do you want to delete this record, something like that? Okay. To avoid having data flow line across each other, you may repeat data store or customer. Or source syncs on a DFD. So use an additional symbol like a double line on a middle vertical line of the data store symbol, or diagonal line in the corner of the sync source square to indicate the repeated symbol. Okay, so this is the additional information for you, but don't worry too much about it. Okay, you can just focus on the disaggregation or aggregation and then balancing here, right? Okay, and then additional keep saying this. Okay, completeness of the DFD. DFD must include all components, okay? Because we need to develop the system based on the DFD, so that's why. Each component must be fully described in the project dictionary or case repository. Consistency, the extent to which information contained on the one level of the set and nested DFD also include one other, so balancing, right? I already mentioned the balancing, right? So other levels, so consistent, terminologies should be consistent, and timing is not represented well on the DFD, so there is no actually time, right, on DFD. Best to draw DFD as if the system never started and will never stop. So iterative development. Analysts should expect to redraw diagrams several times before reaching the closest approximation to the system being modeled. So you should be ready to develop the multiple DFD diagrams. That's why I will give you the exercise for you. Okay, until you have a perfect one. And primitive DFDs, lowest logical level of the decomposition. So it's more like a conceptual, and decision has, primitive DFD, so final version, so lowest logical level of the decomposition, and the decision has to be made when to stop the decomposition. Okay, so that's what you call primitive DFDs. Rules for the decomposition, stopping decomposition. Yeah, you may wonder when you need to stop to draw the DFDs, right? So, right. Maybe level n, after level 1, level 2, level 3, and so on, right? You at some point you want to stop, right, to draw it. So when each process has been reduced to a single decision, okay? The calculation or database, so it's more like if your diagram has only single function, and definitely you can stop. So when each data store represents data about a single entity, right? And system users not care to see any more detail. Right? If your system user does not care to see any more detail, no more detail, then you can stop, right? Right. Also, when every data flow does not need to split, so no need to split, then you can stop, right? And then when you believe that you have shown each business form or transaction online display report as a single, right? Single data flow. Keep saying this, right? When you believe that there is a separate process for each choice on all lowest level menu option, right? You can actually stop. Gap analysis, the process, okay, process of discovering the discrepancy between two or more sets of data flow diagram and discrepancies within a single data flow, DFT. So discrepancy is a difference, okay, between the DFD and the system, technically actual system, more like that. So that's why you need to, once you have DFD, you need to really analyze whether your DFD has an issue or not, problem or not, okay? Also find the differences or discrepancies between two or more data sets or set of data flow diagrams, okay? So that's why you need to conduct gap analysis, and in our exercise we have one. And inefficiencies in the system can often to be identified through DFTs. So we have exercise to actually cover this part. Here is an example of the IBM credit. So credit approval process actually has a 6 days before business process re-engineering, and we have two external entities and the data sources, okay, and data store, and then we have 5 processes. After business reprocess engineering, IBM was able to process 100 times the number of transactions in the same amount of time. So they developed this diagram, okay? A very simple one, right? Context diagram is not the context diagram actually, it's an aggregated more level, right? Because context diagram shouldn't have these data sources. All right. But so what I want to say is that by using the DFD, you can simplify the process, okay? That's what you call re-engineering, process re-engineering, so that you can enhance by reducing the complexity of the existing system, you can enhance its performance, right? Process context, single context here, instead of having so many transactions. Let's look at the example of the DFD. So data flow diagram here. So we will consider the tune source case in this situation, and here is a sequence to develop the DFD. So let's look at this one. Step 1, creating the context diagram. So initially you need to develop the context diagram. So in the project team, begin by creating the context diagram, okay, which is more like a conceptual model. So they read through the summary area of the 3 major use cases to find the major inputs and outputs, okay? So hopefully you remember the previous use case exercise, and the team noticed that the majority of the data flow interactions are with customers who are using the website to browse music selections and make download purchases. There will be an interaction with the payment clearinghouse and entity that will handle payment verification and processing of the purchases, okay? And finally, although it is not obvious from the use cases, the marketing manager will be using the sales information from the system to design the implementation promotional campaigns, of course, right? He's a marketing manager. That's the role of the marketing managers. And the team use the major inflow and outflow from the use cases and develop the context diagram shown in figure 5-15. So here is a figure, and please complete this figure, okay, based on the description shown here. So answers are already given by this sentence, okay? Please read carefully and then solve this question. Okay, so it's not really hard, right? We only have three actors here. So customers who are using the website, right? So definitely the answer of the A should be customer, right? And then what about B? B is customers also interact with the payment clearing house. So payment clearing house will be the B, right? And then third one will be what? Third one is marketing manager, right? So marketing manager will uh, have a decision about the promotion. So marketing manager will go to yeah C. So you got all the answer right of this question. All right. So next one, creating data flow diagram fragment. And next step was to create one DFD fragment for each use case. This was done by drawing the process in the middle of page, making sure that the processor number and name were appropriate and connecting all the input and output data flows to it. Unlike the context diagram, the data DFD fragment includes data flows to external entities and to internal data sources. So you need to be very careful about the connection between the external entities and then data sources. The completed DFD fragment are shown in figure 5-16. So 5-16 is shown here like this, very lengthy, right? It's a very huge diagram here. And before looking at the figure, yes, take a minute and draw them on your own. So take your time, okay, to draw it. But don't worry too much about it right now because you will draw the DFT diagram using software. So there are many good ways to draw these fragments. In fact, there are many right ways. So there is no single solution, by the way. So note that on the DFT fragment for process 3, we have shown the dotted line inflow level time to determine promotion into the process. That's the meaning of dotted line, okay? Recall that we specified that use cases promo tunes was temporal use case, triggered when it was time to update promotions and specials. So dotted line flow into process 3 in figure 5-16. So 5-16 sometimes referred to as a control flow. Okay, you can also type the control flow use a control flow in addition to the DFD, and is commonly used to represent the time-based triggers for an event. Okay, so the explanation about the dotted line here. All right, so if you look at this diagram, and then we have three parts. So this is process 1, process 2, and process 3. Okay, so here, here, and here. Okay, so and each process, so for process 1 includes customer, and then also include the many data sources here, and then there are a lot of interactions, and then so basically customer provide make a request, and then this search and browse tune will provide a result, right, based on the request. So matching tunes and tune samples, also the selection. So if there is selection, and also you provide tune samples, and also in order to do that, in order to conduct answer the as in order to answer the customer's request, actually it has to utilize multiple data sources from such as data 1, data 2, data 3, 4, 7. Okay, so basically data 7 is more like this is shopping cart, so you will provide information to the shopping cart. Okay, here. So anyway, so there are a lot of interactions, and also process 2 required multiple data similar to the process 1. It also, the process 3 is about the purchasing tunes, so there should be additional component called payment clearing house. You are familiar with it, right? We saw this one from the where, from here, right? Clearing house. So technically this fragment has more information comparing to the context diagram. Okay, and last one is about the process 3, so especially the promo tunes, so promotion, so marketing manager actually, and also customer mainly interacted with this process, and then also it has multiple data sources. Good. So anyway, based on this one, we will create the level 0 data flow diagram. Okay, so let's look at this. Next step was to create a level 0 diagram, DFD, by integrating the DFD fragment, which provided to be anticlimactic. Okay, so the team simply took the DFD fragments and drew them together on one piece of paper. And although it sometimes is challenging to arrange all the DFD fragments on one piece of paper, and it was primarily an mechanical exercise. So 5-17 will give you the idea about the level 0 diagram, and you will draw this one. Okay, so question: please draw the level 0 diagram, so shown here using the correctly. So I will explain the more detail in the following actually video. So yeah, you will know how to use this tool to create the DFD. Okay, DFD. I'm sorry. All right. So compare the level 0 diagram with the context diagram in figure 5-15. Are two DFD balanced? Yes. So technically not, but yeah. Notice the additional detail contained in the level 0 diagram. So basically, the level 0 diagram has more information than the context diagram. I already mentioned this one before, right? A careful review of data sources, figure 5-17. So here, if you look at this, and reveal that everyone has both inflow outflow. If you look at it, there is an inflow outflow, right? So with one exception, D1. So this one, if you look at the data 1 here, it only have outflow, right? So available tunes is read by two processes, but is not written to by any process shown. And this violation of the DFT syntax needs to be investigated by the team. So this is actually there is something you need to think about. So because it should have input output, right? So and input output, right? So however, so it only have a one-way direction. So this means that it has a problem. So serious outside, as we will explain later, in this situation, we need to create the process specifically adding, modifying, deleting data in D1 available tunes. So administrative process such as this are often overlooked, as we initially focus on the beginning requirement only, but will need to be added before the system is complete. So that's why we draw the DFD. By drawing the DFD, you can see what kind of item you missed. Okay, so if you look at this one, there's definitely it should be updated or deleted or managed by something, right? But it doesn't have anything here. So that's why if you don't have the two-way flow like a D7, D4, D2, and so on, and then definitely you need to think about the other component, additional component to fix this issue before you develop the actual system. Got it? So yes, please do this one. So let me use the free software to draw the data flow diagram. So let me just create the workspace. In order to do that, you need to create the account for this. Yes, by typing your email address. See? Yeah. So since there are so many free software, so you can use one of them if you want it. And I just choose the software to draw the data flow chart diagram only. So let me draw the data flow chart. Okay, so here type the name of the project, and then we are just conducting the tutorial, right? Example for the tune source company. So tune source level 0 DFD. So we are going to do the level 0 diagram, data flow diagram here. And as you know, so we have I'm sorry, we have search and browse tunes. We have several processes, right? So, and then this one is connected to the several databases. For example, first one is available tunes, right? And ID is 1. And also the ID was 1. This is first process. And then let me just remove this one. Oops. And move the position. Okay, so connected to this first database. So this is a D1. I'm sorry, should be D1. And ID, let's put 2 here for the second process. The second one is purchase tunes. So we are drawing this diagram based on our assumption, okay, based on the assumption given by the textbook. So you can just follow my tutorial. You double click this one, and then you can change the name of the flow, this data flow here. So this one, it should be requested tunes, and then arrow should be opposite, like this. And your shape can be slightly different, but if the direction is correct, then it won't be the problem. Yes. So you have this kind of data. Also, we have yeah, this one is a direction. This arrow of the direction of this arrow is not correct, so you need to have this. All right. Ta-da! Yes. And then add the other data sources. In my case, is because it's difficult to find the shape, and you can copy and paste this data shape. Let me move this one a little bit. So this one is D4, D2. Let me type 2 here. So second one is what? Second one is customer favorite. Then copy and paste, Control C and Control V. So you can have one other one. Oops, sorry. If you press Control Z, actually Control Z, and then definitely you can cancel the previous mistake, cancel previous action. Okay, D3, for the D3, you can type targeted promotions. Right, and then we have D1, D2, D3, and D4. Let me create D4 as well. D4, let me just move the database, location of database, and D4. What kind of data we need? D4 customer interest. Okay, hopefully you understand. You remember the previous example. Okay. Anyway, so search and browse tunes will request the data from the available tunes. and then also it will get the data from the targeted promotions. And this one is what? This one is not just data. Requested tunes. And also let me just copy and paste here. So let me draw another data flow here. And then data flow from these three will be web promotions. And another data flow from the data 2 to the process 1 will be customer favorite. Also, you need to, let me move this a little bit. Okay, let me keep the space for this. Okay, and then another arrow. You can actually use this option, but let me just copy and paste the existing arrow to save our time. And then here we will send the data. So new favorite. So this database can be updated. Also, it will send the existing data to this process, okay? So that this process, search and browse tunes, can operate functions well. All right, and then also another arrow needed, right? Let me just change the location of this one. Okay, needed from here to here. And then we will need to send what kind of information? We need to send the new interest. Right, so that we can get the customer interest in this data source, okay? Right, and then also you can create another one. Let me just copy this database. Okay, then move here. And let's call this one is a D7. So D7 is D7 is a shopping cart. Right. So for the shopping cart, let me copy and paste the arrow again. For the shopping cart, the process can send the data to this database data source. What kind of data source? We can send the tune to buy, right? The shopping cart, right? So the items needed to be sold, and also another arrow needed. So another arrow here from D7 to process 2. Oh, hard to see. Let me zoom in a little bit. Yeah, this is not the best tool actually to do the DFD, but you can also use, actually this is a free tool, that's why I'm using this one. But you can also use a project Visio, the kinds of software, the provided by Microsoft, and then also, yes, Visio will be the good tool to draw any kind of chart here. All right, the scale, let me put the actor here, so this one should be customer. right? Customer should be interact with this process a lot, right? So, oh, I need to change the name of this. Tune to buy, tune to buy. Oh, yes, it's the same. So purchase tune, and then there should be a lot of interaction between customer and search and browse tune. So initially this one is what? Search request, right? Customer can request a search. Also, customer can send what? Customer also can send selection. Maybe here. And then the process should give the response, right? Should respond to the customer's request. Right. This one is a what? Matching tunes. Also, so based on the given request, this process can return the tunes, right? And also, you need to play with this arrow a little bit. Okay, and then tune sample. Okay, and then now we are almost complete the level 0 diagram. Almost. And also we have one more process called promote tunes, and ID should be 3. Okay, it will utilize D3 and D6 and then D5. So you need to create D3 as well as D5. So this one is here. Let's say this one is a D3, D5, I'm sorry. D5, and then cells. And this one is D6. Customers. Okay, customer list there technically. And then I didn't change the name of this. And then this one is tune price. And the customer, from the customer's data source, and then we got the payment authorization. No, we got the customer info. Also customer detail. So you need to draw the one arrow for the one data, okay? One data type. So that's why I need to draw 2 lines here. Okay, and then here, there's customer detail. Let me just move a little bit here. Okay, so, and then we need more lines here, so arrow from source. So let me just move it here. Okay, move this here. And then this one is should be purchase info, and then another arrow is needed from D5 to D3, process 3, and this one is a what? This one is a recent sales. Got it. Also, the arrow from D6 to process 3 will provide customer's email. Okay, and then another data from the customer's interest here. So let me just move here like this. And then data type is customer interest obviously, and then also provided the updated data to the customer favorite. About you website promotion. So once you have customer data, definitely you need to have you can utilize it to for the marketing, right? So customer, it is, I'm sorry, yeah, link is it was wrong, so it should be here. Yes. So this information is used for the marketing. Okay, so this is we're almost done. Yes, and then let me see what kind of information I need to provide more. Oh yes, another actor. Payment, clearing house. So we have three, right? Three object, right? Clearing house. So let me just increase the size of this. All right. So and then there should be the interaction with this object with the process, and then payment authorization will be here, and then you can send payment, right? So that you can actually have a payment. Oh yes, as these two are the only interactions actually between payment clearinghouse and then purchase tunes, and then also customer. Actually, there is a lot of interaction between customer and this process. So let me move this arrow here. Shape is weird. Let me just change a little bit more. It's not pretty. Okay, so let's copy and paste the other arrows. And this is what? This is a tune download, so that customer can listen to the music, right? And also another arrow from 3, process 3 here. And then this one is email promotions. Yes, and then last one, last object will be marketing, right? Manager. Marketing managers can handle the sales information, right? Oh, sorry. Okay. Oh, yes. So we are almost end. I keep saying this. I keep saying this. Yes. Yeah, we need more lines actually from here to here. Hmm. Customer account info. Not only account. Also, we need customer info and also payment info. Uh, Please note that this is the only solution you can have, okay? I try to address the major items you need to consider to develop the e-commerce website. Uh, Payment info. Right. All right, so something like this. So now we have I have 7 data sources and then also 3 processes, right? The 3 actors, right? Object here. So let me just zoom out a little bit, right? So you can copy this one and then paste it. So if you just click this button and then you can choose choose the option. Let me just use a PDF or JPG, right? And then definitely you need to sign up. Okay, so but So once you download the file, and then you can put your DFD flowchart to this your document, okay, so that you can have a clear idea about your project. Number 4, creating level 1 data flow diagram and below. So next step was to create level 1 diagram or DFDs for those processes could benefit from them. The analyst started with the first use case, search and browse tools, and started to draw the DFD for the individual steps in contained. Although steps in use case were straightforward, but as is common, the team had to choose names and numbers for the processes and to add in input data flows from the data source not present in the use case. The team also discovered the omission of the data flow customer interest from the use case. See figure 5-18. So see figure 5-18. So this is a figure, and then you can see the more detail about the specific process here. Okay, so process 1. This is figure for the process 1. And also the team also developed a level 1 diagram for other processes using the major steps outlined in their prospective use case. Some adjustments were made from the steps as shown in the use cases, but the team followed the steps fairly closely. So see figure 5-19, 5-20, and compare them with their use cases shown in 4-14. So basically we have two more figures here, 5-19, okay, and also the 5-20, and definitely you need to complete this one by yourself. Yes, I'm sorry. Yeah, I keep trying to give you the many questions in this example. Okay, every data store should have one or more input data flows and one or more output data flows. A careful look at figure 5-18. However, reveals that the one available tools has output data flows, but no input data flows. We already mentioned this, right, before. This data store is the main repository for the digital music library. So clearly, it has a central role in our system. The team will need to be sure to create the administrative process for maintaining this data store, add new information to it, modifying its existing contents, and removing information from it. So these administrative tasks are sometimes omitted from the business-oriented task listed in use cases. So that's why you need to draw DFD, right, after the use case. So it is up to the team to ensure the processes are including add, modify, and delete the contents of the data stores somewhere in the system. And simply checking the DFD syntax, all data store must have at least one input data flow and at least one output data flow. Help discover this omission in the process model. So this sentence keeps saying same thing, right? Although it would have been possible to decompose several of the processes on the level 1 DFTs into more detail on the level 2 diagram, the project team decided that that step was not necessary. Instead, they made sure that the process descriptions they created in the case repository for each of the processes was very detailed. This detail would be critical in developing the data models and then also the designing the user interface program during the design phase. So don't worry too much about design phase. Yeah, I will mention about it later. So you can focus more on the DFT part, okay, after the use case development. So here we have two figures, this one and this one, and yeah, please draw this figure by yourself using the tool, right, addressed in before, so this tool. And then after that, yeah, please also complete this one, okay, complete this one. So technically, yeah, you need to draw two more DFD diagrams using tools so that you can get familiar with it, get used to it. And then after that, you can complete this figure. So complete this figure, and then I already give you the list of options here. So 3 options, right? So one of them should be the answer. So all these 3 options should be answer of these blanks. So fill in the blanks by yourself, please. Number five, validating the data flow diagrams. So the final set of DFDs was validated by the project team and then by Carly and her marketing team uh, in the final JED meeting. So we will learn about JED later. So next time, there was general approval of the customer facing processes, process one, process two, and considerable discussion of the specific information that will be required to help the marketing team make each promotional campaign decision. This information was recorded in the case repository so that it could be recalled during the development of the system's data model and the subject of our next chapter. Yeah, I told you so, right? So yeah, we will discuss these topics later. Okay, next time. Thank you.